Hello everyone. Welcome to Team YMCA's final presentation about our project CDC Guidelines Decision Support System. We are 4 team members representing the team. Myself Dinesh, John, Rajkamal and Yuping. Our project is about a decision support system based on CDC guidelines for Zika virus. Project scope and business case. This decision support tool can help practitioners making an informed decision for a patient based on Zika symptoms, or any other factors like lab result, Zika related symptoms, or patient's travel history to the Zika affected areas. This tool can save valuable time in identifying the potential diseases and ultimately will lead to timely treatment of the patient. How our application relates to FHIR server. Our application makes API calls to Georgia Tech FHIR server to get resources like patient details, lab results, and symptoms contained in observation resource. The data is then fed to the decision algorithm based on Bayesian network for Zika infection probability calculations. If the probability of the patient infected with Zika is, let's say, more than 60%, then the practitioner is alerted to follow additional CDC Zika guidelines for the patient. Following diagram suggests how the application works in real-world scenarios. Let's say a patient walks into the doctor's office. The doctor pulls up the patient's EHR using the Smart on FHIR app in his system. The doctor then updates the patient's EHR based on some questionnaires from the patient and saves the latest patient information in the EHR. Now once the doctor updates the EHR record, our application is triggered. The application reads the latest data from the patient's EHR that was updated and then runs the decision algorithm that matches certain criteria from the patient's EHR with that of the submitted guidelines from the CDC. The decision algorithm then provides an output if the patient has possibility of Zika or not. This information is then displayed to the doctor suggesting that high probability of Zika infection is detected. Please follow CDC guidelines for the patient. This slide represents our decision support system's data flow. The intentional production graphical user interface for this project is contained completely within the client's EHR. In an ideal scenario, a practitioner while working on patient's EHR will get a pop-up on his screen suggesting that the patient meets certain criteria for possible Zika infection and to follow further Zika guidelines for the patient. As this project serves a proof of concept, we are simulating the flow via JavaScript, HTML and CSS. The algorithm based on the Bayesian network will display the probability of patient's Zika infection to the same simulated EHR. For a production deployment, our user interface code would be replaced with CDS hooks calls to display an information card triggered by the patient view hook. Following 3 slides represent our algorithm and the work we have done. In the context of medical diagnosis, a Bayesian belief network is a directed acyclic graph in which diseases and symptoms as well as test results are graphically represented as nodes. The root node represents diseases while the child node represents symptoms and test results. The basic task for the diagnostic algorithm is to compute the posterior probability distribution for the Zika disease given some evidence variables, which in our case are symptoms and lab tests. The algorithm calculates the probability of Zika given evidence symptom 1 and symptom 2. This is known as diagnostic inference. We consulted ILiAD medical expert system, which has alternate results depending upon which combination of findings are present for evidence. It does this to circumvent the problem of non-independence by only using evidence which has a higher importance to perform computation. However, our algorithm, in case of symptoms and lab tests, assigns weights on evidence that has higher prioritization like lab tests and lab results and lower weight to symptoms. For example, if a lab test is positive for Zika infection, we do not need to look at anything else, do we? For the category that require multiple dependencies, the sensitivity of the category is fine-tuned with Boolean logic expression to describe the contribution of each element. In our case, if both lab test 1 and lab result are positive, then this case has a given likelihood of Zika infection. Similarly, if lab test 1 and lab result are negative, then it has some another likelihood. Following 2 slides suggest how our decision algorithm works. Central piece of the project is formulating a guideline format to work within the decision support web application. Our finalized guideline format is one that takes weights and likelihood for each rule to make posterior prediction in the form of medical diagnostic inference. We're also given information from the CDC website that contains multiple value set dictionaries for Zika related symptoms, lab tests, lab result code, and travel area code. These detection values form the basis of our rules. Then from these dictionaries and from our knowledge of fire data resources, we came up with a guideline format that combined CDC guidelines, fire, and medical diagnostic inference. Interested folks can look at these flat text files containing guidelines under Guideline Directory. We created our own machine-readable guidelines in CSV format. Our guideline format gives an option to add and remove standardized coding for symptoms, lab test, lab result, and Zika affected areas. Our guidelines format also has the ability to assign probability and weights to each rule. Each rule can work on one medical code or group of codes in conjunction on the same row. When we input the Zika guideline into our algorithm engine, it is found that none of the Georgia Tech fire patients have Zika symptoms. So for this demo purpose, we created another guideline to specifically identify patients with serious illness in addition to Zika virus detection. This simple guideline spots patients with frequent lab tests and emphasizes more on the tests like chest X-ray and more severe conditions like acute or chronic diseases, and emphasizes less on tests like visual inspection and visual findings. This is our updated Gantt chart. We have finished the development, integration, and testing of the application. We are delivering the application and all the related documentation to the mentor along with the final presentation this week. Let's have a look at the project demonstration. Our application runs on an Apache HTTP web server. Via the Get Data module, it makes API calls to GATech Fire server to get patients' resources and simulating an EHR-like behavior. The application then makes calls to the Python-based decision algorithm application and presents the probability of the patient having Zika infection. Currently, the set threshold of possible Zika infection is set at 60%. Let's assume the practitioner is working with a patient, Mr. Kramer, with patient ID equal to 10. The doctor now updated Mr. Kramer's EHR and nothing happens, as the calculated Zika probability for Mr. Kramer is less than 60%. In a real-world scenario, the doctor will not get any notification or alert if the threshold is not met. Let's take another example of Mr. Douglas, patient ID 200. In this case, the probability of Zika infection is calculated based on Mr. Douglas' lab results and current symptoms as 99%. This kind of high probability means the patient has all symptoms based on CDC guidelines, and the doctor should follow next steps for Zika diagnostics like a lab test. It is possible that the doctor was not even aware of Mr. Douglas' possible infection, or maybe Mr. Douglas doesn't even have Zika infection. But following further guidelines and making further probes will only help avoiding or treating Zika in advance. Thank you. Future work and challenges. Currently, the CDC guidelines are not machine readable. In future, we are hoping that CDC will provide machine readable guidelines along with weights of each symptom in identifying a disease. This is crucial in developing any decision support systems based on ever-changing and overly complex CDC guidelines. Another future work can be the integration with real EHR or CDC hooks-like service to present the triggers to the practitioners. Some of the challenges that we faced were related to real data not being present. We had no EHR access or patient's travel history. We had to host synthetic data about the symptoms and their weights to fed to the decision support system that we had. Thank you and have a great new year ahead.